Okay, question 17. So here it rises by 3 centimeter. So it rises by 3 centimeter. So
The other side drops by 3.
here it will drop by 3 centimeter, right? So altogether, the level differences from here to the top here, it's going to be 6 centimeter. So 6 centimeter, right? So the new level differences. So 6 centimeter is actually tells you what the pressure differences. Right? The pressure differences is the 6 centimeter. So the pressure differences is 6 centimeter. H rho G, where your H should be 6 centimeter or 0.06. Okay. So using 0.06 and density, density is gram per centimeter cube. That means H, you just leave it as centimeter. Oh, too much. Okay. Oh, it's gram per centimeter. So, okay, you put it 0.06. We put it in meter. The density we change to kg per meter cube. You have to kg per meter cube. How much? Times or divide by 1000. Gram times by 100. Yeah, times 1000. So 13.6 times 10 to the power of 8, right? 10 to the power of 3, sorry. Change to kg per meter cube. Then multiply by your gravity. You should get your answer. The trap is this rise by 3 and this drop by 3, so it should be 6.
And times 9.81 at the end.
Yeah,
Is
time,
it?
yeah. 9.81.
Yeah.
Because you want to find pressure. Right? So H you put in meter, density you change to kg per meter cube, 13.6 times 10 to the power of 3 kg per meter cube.
Correct.
So you get what? You get which answer?
8.004 kPa.
So D, okay.
Donkey.
So that's the trap. 3 centimeter rise means here 3 centimeter drop. So total is 6 centimeter. Okay. Pressure difference. It's a manometer. Any other question?
No.
That's all.
Wait, let me check.
Wait.
Okay, that's it. Anyone? Any other questions?
18. Oh, okay.
38 is it? 38.
38 just now already discussed.
What number?
Yeah.
18. 18.
Yeah.
18.
Oh, 18. 18.
Okay, 18.
Answer is donkey.
Okay, 18 density. So a liquid density of rho mass m is thoroughly mixed with another liquid of density of 2 rho and 3 m. There is no change in total volume. What is the density of the liquid mixture? One is rho, another one is 2 rho. Okay, so we assume this as a mass of m and as a volume of b. We assume this we introduce. Okay, so m and b. The liquid currently mixed with another liquid, 2 rho and mass 3m. With another liquid. There is no change in total volume. Mass m. Okay, so now the 2 rho as 3m. If it has 3m means how many v? How many v? 2 rho. Rho is what? Rho is mass m over v. If 2 rho means if mass is 3m, V should be how many V? V should be how many V? To get 2 rho. Should be? Because you want to get 2 what? 2 what? 3 divided by what? You get 2.
3,
Three
2 over
divided.
3.
2 over 3. 2 over 3. 3 over 2, right? 3 over 2V, right? Right? 3 over 2V, right? So 3m divided by 3 over 2V, you get 2 rho, right? Correct? 3 over 2V, no. The material which has a 2 rho of density, first we go to the material with rho. With rho, mass is m, V is V. 2 rho, 3m divided by 3 over 2V, you get 2 mv, no? So 2 rho. Okay, so it should be 3 over 2V. So these two added, you go to the new substance. So this new substance, they're asking for the density, new density. So for this new substance, how much is the m going to be? So m plus 3m is going to be 4m. The v, here 3 over 2v become what? 2.5v. 2.5v. So what is the new density? So new density is, of course, 4m over the 2.5v. 2.5 is actually 5 over 2, right? 5 over 2v. So it's actually how much?
8 over 5.
8 over 5.
8 over 5 rho. P. So always.
13.
What is the next question? 30.
13. 1, 3.
Okay, we go to 30. This question. Okay, question 13. The shape of the shape shown below is cut from a uniform sheet of metal. At which of the point is the center of gravity most likely to be found? Okay. So normally, if it's like the shape shown below is cut off, at which point the center of gravity most likely to be found there? So A. So here evenly distributed, up, down, nothing. You see, if it's a close, so one complete rectangle means connected, no hole here. The center of gravity will be like the geometrical center. We'll put across something like at the center here. Sorry, my diagram is wrong. I think at C, C here. If it's a completely one rectangle, if you have a empty part here, means the center of gravity should shift up. Answer is B.
Yeah, the answer is B.
The given is B. Okay. What is meant by center of gravity? This is center of gravity.
The point where all weight is considered to act.
Yeah, the point all weight is considered to act. Okay. Center of gravity is same as center of mass. If our gravity is uniform. Center of mass is not in your syllabus, but in this case, I think I need to tell you about center of mass. Center of mass means if you have a body here, center of mass is a point where the mass is evenly distributed in all directions. Okay. Here you get the same amount of atom. That is the center of mass, let's say. Here also you must have the same amount of atom as the left side, the counterpart. This must have the same amount of atom here. Okay, that's the center of mass. Center of mass, center of gravity is normally the same point. So here, if you go at A, the mass is evenly distributed here. Here, not same. If you go to A, can you balance it? You can't balance it at A. If you put a finger here at A, can you balance the thing? Can you balance it? You can't balance it, If you put your finger here, like what you call, like this shape. I put it like this shape. This, and you put your finger here. Okay, you're going to collapse. You're going to collapse. Okay, so center of gravity is the point where you can balance it. So A, definitely you can't balance it over there. So the center of gravity for this body is out of the object. C happens only if it's a complete rectangular shape. Complete rectangular shape, the C is yes, that's the center of gravity. It's a perfect rectangle. You can balance it at the center. Okay. But when this become empty, your mass is more on top, mass on top. So the point will shift a little up there because you have mass lies here, nothing. See? But it won't fall at A because at A you can't balance it. Or in other words, if you hang this, here, you're going to be like this. You're going to be like this. You make a pivot here at this point. So I think you're going to hang like this, I think. Like this. So this is where the center of gravity lies. If you use a plumb line. So the center of gravity is definitely going to be out of the object. So you put here later the plumb line here, then you're going to be like this, I think. Okay, it'll be like this. So a plumb line. So it's normally fall out of the object here, somewhere here. It won't be C. Why it can't be C? Because C happens if it's a perfect rectangle. Yes, the C. If you have an empty slot, it'll go a little up. So definitely won't be D, because D, the mass is not evenly distributed up and down. Okay, so you have to get closer to this mass. So you have to be in between A and C. Okay, so that's why benefit of doubt we go for B. C when it's perfectly rectangle. A cannot go to A because it never balanced at A. You can't balance it at A. Can't balance it at A. That means center of gravity not there. Okay. So the center of gravity is between A and C. Okay. That's the explanation I can give you for this case. And so because on the left the mass and to the right mass is balanced, so you should go up a little. You should go up. So B is the answer. Cannot be D. You won't go further down. If you go further down, mass here and here are not same. Mass here and here like not same. So it won't be D. You should go up here. Okay. One of the difficult questions. Any other questions?
Teacher, question 14.
14.
14, yes, 14.
Yeah.
Okay, 14. Okay, 14 is an inclined surface. So block M is slide down an inclined plane at a constant velocity shown in the diagram. E0, or the total mechanical energy of the block at the start of the. What is the total mechanical energy of the block after traveling a distance of d down the plane? What is the total mechanical energy? Do you have a friction? Is there any friction? Never state that
Yes.
The diagram, but it's on a diagram.
There is.
As a constant velocity, that means got friction lah. Okay, what is meant by mechanical energy? The EP plus EK is a mechanical energy. So work done by the thrust equals to what? Gain in EP plus gain in EK plus the heat, right? The heat. Okay. Heat or work done by the friction lah. This is your mechanical energy. Your EP plus EK is mechanical energy. So what is EP plus EK will be? Actually the work minus with the heat. Work minus the heat is your total mechanical energy. This is your mechanical energy. Okay. When it goes down, there will be a heat generated more, right? More work done, more heat. So this value, is there will be any difference? That's the answer, right? Yeah, this answer. The original, if E naught was the total mechanical energy of the block at the start of the motion. That this E naught is what? This E naught. E naught is the total energy it possesses lah. E naught. Let's say E naught. Okay. So of the block after traveling a distance d is, so answer is what? E naught minus
FD.
heat is how do you get heat?
Friction.
The friction times the distance, right?
Distance.
So F times D is your change in mechanical energy. So E naught minus FT. That's answer. What's the answer given? B.
B, yeah, B. It's B.
Yeah. Because
Yeah.
total energy was the total work done, the thrust, the total energy it has. This is the total energy it has. Then when you slide down, heat will generate. So this mechanical energy will drop. This drop. So the total minus the mechanical energy possessed after you travel a distance d. This differences your heat. That's your heat. So they're asking what is the final mechanical energy. So the total energy E naught minus the heat generated, and that's the remaining mechanical energy. More heat generated, more or less mechanical energy will have towards the end. So it should be B. Cos theta.
Yeah.
So B is the answer. Okay. Can get it? Anything you want me to clarify more?
So, question 19 and 20.
19.
19.
Okay, question 19. Okay. A metal ball 2 kilogram traveling 8 meters per second strikes another metal ball 4 kilogram traveling at 2 meters per second. Both metal along the same straight line. After collision, 2 kilogram ball continues moving with 5 meters per second. Oh. So after collide, they found 2 kilogram is moving with 5 meters per second. To the right or left?
Right.
Never say that. 5 meters per second, while the 4 kg balls continue. We don't know where it moves, 5 meters per second. Okay. Then 4 kg is balls continue to move with V. So 4 definitely should move to the right due to impact. This is V. Okay, what is the magnitude of the velocity V? Okay, total momentum before is equals to after. So 2 times 8
8
plus
plus 8.
equals to this
24.
10. 10. It could be 10, it could be negative 10. We don't know after collide moving fast. It might rebounds with 5. It could be 10 or negative 10. We're not sure here. Two possibility. Last 4B. We assume first to the right. Okay. And what's the answer you get?
Donkey.
Get and so you get donkey. So you get 3.5.
Yeah.
If you take this as negative 10, you get plus 30 divided by 4. How much? 34 divided by 4. If move to the left, this move to the left. 34 divided by 4, what do you get?
3.5.
3.5.
8.5.
3.5.
3.5.
8.5. 8.5.
34 divided by 4.
Teacher, why you got 34?
34.
Or why 34?
Did you say if move in another
Teachers.
direction?
If this is the right, this is the working. If this,
Yeah.
it can move to the left too, right? Can move to the left. Move 5 like this. Then the 10, become what? The 10 will be negative
10.
24.
Negative 10.
Oh.
Negative 10 plus. This is another possibility. So you get 34 over forward. So you get 8.5. 8.5.
Okay.
And we don't have 8.5 here. So go for 3.5. So two possibilities. Because this one can collide and bounces back. Very rare, but it bounces back. Like a ball is thrown to another one, hit, and it could bounces back. Or you move to the right. Both can. Never really clear here. So two options. Okay, 3.5 is the best answer given. So D is answer. Total momentum before equals to total momentum after. You draw diagram. I normally draw diagram. Okay, my teacher always trained me draw diagram. So maybe better. Any other question?
20.
20.
Yeah. Okay, 20.
It's A. The answer is A. The answer was wrong.
Oh yeah, just now we discussed. The answer is actually A.
Oh.
A. Okay.
The given is wrong.
It's not C, right? It's not C, right?
Not C. 20 is A.
Okay.
Any other question?
Wait, teacher, can you discuss it? Because like just now I wasn't here. 20.
20, yeah.
Yeah.
20 because the force here acting up and weight acting at the center down. So we take moment about the pivot. Taking moment here. Okay. Pivot. So moment caused by the weight times 1.25. 1.25 because half of the length. 1.25 should be equal to the 300 times its distance now from here. Which is 2.5.
2 meter.
2 meter. 300 from the pivot. Oh yeah. So 2.
Wait, is it 0.5?
No, 2. Sorry. Oh no. 2. Yeah. Sorry. 2. So you get your weight. Then weight change to mg. So you find the mass. So divide by the gravity, get mass. So you should get a 49.
Okay.
Wait, you repeat again?
Yeah. To understand this, right? By the weight times 1.25 should be equivalent to 300 times 2.
2.
I think the 2 is
So now we want to find the weight.
you
Weight
want
equal
to
to
mass.
mg.
You want to find the mass, right?
Oh, find the mass. Mass equal to mg. So I need to divide 9.81.
You get the mass. Yeah. Okay.
8.
8. Okay. So you go to 8. Okay, question 8. A free falling object on Earth has a speed of 5 meters per second. After falling a further 20 meters, this is your kinematics, right? So you have to find out one of the kinematic formula. You know this is what? This is your S 20 meters as A, you should know, is 9.81. Okay, so you know 3 informations, you know, S you know, A you know, you're looking for V, right? V, final speed. So V equals to what formula? Formula without time, right? So V squared equals to U squared plus 2AS to be used. Find your S. So you can, U is 5, so 5 squared plus 2A 9.81 and 20 meter square root. So you get your V. What is that?
20.
So 20, yeah? You get 20 here.
20.
Wheel. So it's a
Teacher, what about number 7?
number 7.
Number 7.
Okay, 7. Seven is a stone is thrown upwards to a cliff after reaching a maximum height. The graph shows the vertical velocity v. The stone carrying empty after thrown upwards. R and S are magnitude of the areas of the two triangles. What is the maximum height above the sea that the stone can reach? Thrown. Okay. You see, so this is the cliff. So this is the sea. Yeah, this here is the sea. The ball is thrown upwards from the cliff and come down. Okay. So your S is which distance? Which this area is which displacement? This one, you know, your S.
Yeah.
R is what? R is from here to here. That's your R. Not the question one. The question one, what is this distance? They're asking what is this distance? The distance cliff to the sea. So R minus S would be R minus S. Okay. Makes sense. Any other questions?
Wait, stop.
Wait,
The answer is B or
B.
D? The answer is B though.
Given B.
B lah, R only ah.
B, right? Oh, okay.
B, right?
Why you
B.
put R minus S?
Answer
R
given.
minus S is the height of the cliff.
The chair. Okay.
Graph
Alright,
shows
alright.
vertical. Answer given is what?
B.
B.
It's
R.
B, it's B.
R. What is the maximum height above the sea that the stone can reach?
Yeah, above the sea. It's like
Above the sea. So you throw up. See
Yeah.
how far can you reach? So
Oh, yeah.
it's R.
This R, sorry. They never asked what is the height above the sea. They say what is the maximum height of the sea. So R,
Maximum height.
so R only now.
It's not only the cliff
Yeah.
height.
Here to here. R, sorry. Answer is B. Any other question? We don't have questions. We can go to paper 2.
Wait, teacher. 23. 23.
Okay, 23. Diffraction. Diffraction can be observed when a wave passes an observer obstruction. Diffraction affects greatest when the wavelength and the obstruction are similar in size. Yeah, best diffraction happens when the separation is same as small wavelength. For waves traveling through air, what is the combination of wave and obstruction that could best demonstrate diffraction? This is
A, because steel posts can stop microwave.
microwave.
So
So
when steel posts stop in front of microwave can't go through the thing.
okay, what is diffraction means? Spreading a wave, right? Spread. Spreading is best, and the gap is same size with the wavelength.
Okay.
That's what we know, right? Diffraction. So A must be about same as wavelength. The diffraction is the best law. Okay. So now you have to use your check. What is the microwave wavelength? Do you know the microwave wavelength? What is the wavelength of a microwave? The fact you need to remember from what? From gamma ray to X-ray, right? So what is your microwave wavelength? Anyone?
1 times 10 to the power. Is it 2? I don't know.
-2. -2 meter.
Oh,
-2 meter. How many centimeter? 0.01.
1.
So 1 cm. So the wavelength of micrometer is 1 cm. 1 cm. If the steel post, you have a steel post, one steel post, you have another steel post, or passing a steel post, like one steel post. The steel post width can be around 1 cm. Steel post is bigger than 10 cm. I think the steel post could go like 10 cm, around 10 cm. 10 cm width. Okay, 1 cm, 10 cm. It need to be same. Okay, there is some difference about 9 cm. We check the others. We want to see which is the closest between A and lambda. You go for second one, radio wave and copper wire. Radio wave, how much? Radio wave is 10 to the power of 0. It's like 1 meter, let's say 1 meter. Radio is 1 meter. 1 meter, copper wire, what is the copper wire is about few millimeter, right? Copper wire. I think B is worse than A. So B cannot be the answer. A is still the best compared to B. Look at C. What is the wavelength of sound wave? Anyone? Sound wave, what is the speed? 300 something.
300.
Frequency of sound wave, we can listen. We can sense up to 20 to 20,000. Okay. You put 20. What is the wavelength you get? It's under 50. How much? 15. About 15 meter. Sound wave wavelength is 15 meter. Okay. A human air size is micrometer, right? Micrometer. In micrometer. This is even worse than B. So C cannot. Still A looks okay. D, visible light with the gate post. Visible light is 10 to the power of -7 meter, wavelength. But the gate post is how much? Gate post, maybe gate post, 1 meter. 1 meter. So this also not a good closing to A and lambda. I think the best A and lambda quite close is the A. Micrometer is 1 meter. Micrometer just now how much you got? 10 power -2. It's about 1 cm, and the post is 10 cm. I think that's the smallest differences. Which A can say quite close to wavelength compared to B, C, D. So I go for the best option is A compared to B, C, D. Okay, so the biggest diffraction happen is for the A among B, C, D. Okay, but if they do this experiment, microwave, radio wave, sound wave, visible light, all comparing with steel post, which diffract the most? Microwave, radio wave, sound. Yeah.
Radio wave.
Which will diffract the most? The one with
Longer wavelength.
the one with the longer wavelength. Which has the longest wavelength? The
Radio.
sound wave.
Eh? Oh.
15 meter.
Sound wave.
Sound wave.
Okay.
And in this case, sound wave can't show us the diffraction because the human hair is too thin, too thin, so it won't diffract. Okay. So answer is A. Any other question?
25.
25, huh? Okay, 25. What is the order of magnitude of frequency electromagnetic wave in the visible range? For this, it's a fact to remember, right? You have to remember the fact again. Wavelength start with what? Your gamma, 10 to the power of how much? Negative 12.
Negative 12.
Oh.
Then increase by 2, right? What is that? Finally, you turn to become MR. R become 10 to the power of 0. Okay, so this what is the visible spectrum? Visible spectrum, no need to go to this, but you should know visible spectrum from what to what wavelength? 4 to 10 to the power of what? Negative 7, right? 2, 7 times 10 to the power of negative 7. This you need to know one. So what is the frequency? So V equals to F lambda. I use V equals to F lambda is here. So what is the frequency? So speed 3 times.
Times 10 to the power.
Divided by, maybe you can go for this wavelength. So 7 times 10 to the power of negative 7. What do you get? So 10 to the power of 8, 10 to the power of 7. So I think 15. Quite big. 10 to the power of 8 divided by, yeah, quite big one. What is the order of magnitude of frequency of electromagnetic wave in the visible spectrum? 1016. Cannot be what? 10 to the power of, this is 10 to the power of 20 now, Gamma. 10 to the power of 18. 10 to the power of 14. 10 to the power of 12. 8 plus 8. Yeah, cannot be the answer. It would be quite